welcome, everyone. Thanks for joining my session. I'm going to talk about embedded data processing and synchronization in mobile applications. My name is Marian Puhl. I'm a solutions engineer at Couchbase. I have pretty much my entire life I've been working within IT, mainly working as a developer. Been working as an architect for integration and solutions during the last couple of years mainly. How many of you are developers? It's a developer conference, so obviously most of you. How many are working more on the mobile side of development? Okay, and perhaps on the back-end side supporting mobile applications? Yeah, okay. Okay, so what I would like to address, we have like 40 minutes. I would like to do a very short introduction around Couchbase, then look into different patterns, pretty much how do we consume data, how do we process data, usually on mobile or edge devices. Look into a couple of use cases as well, and then what's pretty much most important, I guess, is to show some live demonstration, just to give you an understanding how a certain pattern can work. And then I would we'll try to keep some time in order to allow for any questions you may have. Okay, so just initially, on a very high level, you may not be familiar with Couchbase because the name Couchbase doesn't really say what Couchbase is about, what this is. Couchbase essentially is a highly scalable distributed data platform. You have integrated cache, a document store that allows you to essentially work with your data and read and write your data really, really fast. So there's no need to put any type of cache, for example, in front of Couchbase because you're literally working through memory when you use the platform. As a document store, you typically store the data in JSON documents. You can also, of course, store binary data if that's needed. But the advantage of JSON is that you can easily index the data using indexing, and that then allows you to essentially run SQL queries on your JSON data. So essentially, the same syntax that you know from relational databases, select this and that, you can essentially run on JSON documents instead. And there are a variety of other capabilities in the platform, of course, as well. But let's get to the topic of the presentation. So in a traditional architecture, traditionally how we build applications, let's say we have the cloud. In the cloud, we store the data, we do the data processing, we do analysis of the data. And then, of course, depending on how important this particular application is for our organization, we make sure it is highly available. We make sure we deploy and distribute the data across different availability zones, for example. We may want to be able to support even the outage of certain regions in the cloud, so we make sure we replicate and kind of duplicate the applications within different regions within the same cloud provider. Some go even a step further. They use, for example, one cloud provider and a different cloud provider, and use essentially the other cloud provider as a backup for the first cloud provider. So there are a variety of options, and really depending on the requirements for your applications, you essentially choose what the right architecture is. Then on the other side, we have the clients. Of course, there's lots of data processing in the cloud, but of course you also need to process and want to process and use the data in some devices, for example. And there are lot of focus is spent on the UI, how is the experience for the user using the applications, how is the flow through the application in order to ensure that the users actually continue using the application and so on. So these are like two focal points, and these are two things we can, when we develop and design the solution, we can easily, or not necessarily easily, but we pretty much, they are in our control. So we decide what to do about it. We decide, okay, do we need high availability or not, for example. But then again, in the traditional application, typically, the data is accessed from the client and fetched from the server, right? So in a sense, we have something in between. We have the internet in between, the network in between, which we can't really control. We don't have any control over. So we can control the cloud environment, we can control the client code, but we can't really influence, okay, how does the user experience my application, for example. So that means, of course, that's quite obvious, right? Is the internet going away? And these are some screenshots from applications that I'm using on my phone. No matter how good the infrastructure is down there in the cloud, no matter how good the user journey is thought out in the UI and the application, if there's no internet, the application becomes completely useless, right? That's kind of an extreme case. You may argue that, I live in Stockholm, I live in Malmö, I have connectivity everywhere, right? But of course, there are other places where not guaranteed to have connectivity. Could be, go in a basement somewhere, for example. And as one example, if, for example, UPS delivers a package, they essentially have some type of, it's not an iPad, or some type of device, essentially, with the route and all the packages, the delivery information, and so on. They knock on your door. You have to sign essentially the order. So imagine where you live in the basement, maybe, I'll make this up now. The connectivity is not good enough. So what would this result in? Yeah, essentially, he would stand there, wait, for the page to load, for you being able to actually sign it. That's of course not a good experience for you, but it's not a good experience, or especially not good for the UPS person, because he has a route to follow, he has to deliver a number of packages, and all the other recipients, they also kind of expect a prompt delivery of the package. So looking at this, so if you want to do the processing on the client, you have a couple of dependencies, or mainly dependent are you on the availability of the network, but also on the latency and bandwidth. So it's either works or not, and sometimes, and I experience this quite often. It's just slow for whatever reason, right? And that's not the best experience to have. So what can we do about it? It's simple, right? We say, okay, we bring the data closer to the user, right? We have our data center somewhere in order, to provide a better experience and to provide or to support different kind of use cases. We essentially need to bring the data closer to the user. And it's also known, pretty much as you may have seen it before, as edge architecture, where you essentially, on the very top here, you have the cloud, the cloud I was talking about before, your data center, data store, your applications, crushing and processing, essentially all the data you are working with. Then in order to be able, to allow for prompter processing of the data and even allow to process the data locally or closer to the user, you have the concept of edge data centers. An edge data center, for example, typically, for example, it's a warehouse where you completely autonomously, you know what I mean, you essentially, pretty much in this isolated warehouse, you can essentially collect all the information you need, do all the processing needed. Another example is, for example, boats on vessels, on ships. They also often have some type of local data center on the boat in order to be able, for example, to process sensor data. Okay, how are the waves going? What's the fuel consumption and so on, right? You do not want to rely on the data actually is sent all the way to the cloud and then processed over there, and then you get the result back. So it's really about being able, to act on the data as fast as possible. And of course, there are other aspects as well, because connectivity on the sea may be very limited, and of course, could be potentially quite expensive if you, for example, use this as satellite connection. If you go even one step further, we have processing of data directly on the clients. So for example, on your mobile phone, on your iPad, some type of embedded device, where you essentially take the data all the way down to the device, and by this essentially become completely independent of network connectivity, right? And in the next example, that's pretty much what I want to show. So, yeah, how do we, provide this better user experience? Yes, we just take the data closer to the client. We put the data directly on the device. There are various ways to do that, right? So you can cache the data, you can store the data locally, or actually a portion of the data because you do not want to have the full database on your local device. You just take the snippet, that's really relevant for this particular use case and user. But then again, we have a challenge. We have better user experience because now the application, since we work towards the local data, will be significantly faster, will be work even if there's no connectivity. But all of a sudden, we have to worry about how do we keep this data up to date? How do we guarantee that the data actually on the device is consistent with the data on the cloud? And also, we are adding kind of complexity to the application, right? So that needs to be handled and managed. And besides the synchronization aspects, and I call this developer's nightmare because initially you think, I can build this, I can sync it, but then all of a sudden, iteration after iteration, you realize, there are a couple of more things to consider. One of them, for example, as I said before, you only want a portion of the data. You do not want to take your terabytes of data from your real database, just a portion that's important. Of course, you need access control. You want to ensure that the user using the data is actually entitled to read and edit the data. So for example, there are use cases for like mobile hospitals, right, where doctors essentially have the patient information on mobile devices completely available offline. And that's personal information, right? So you would want to make sure that only the right doctor is allowed to actually see the right portion of the data and can work with it. The same with the UPS guy. You would want and expect that the person only sees the current route he's going, only the packages he's delivering, and he should not be able to mark some other packages as delivered, for example. Then, if you support offline, of course you will have conflicts, right? You can try to model your data around it, trying to avoid conflicts, but in many use cases, there will be conflicts. You have multiple devices operating on the same data set. They may be updating the same document. Okay, and then eventually the data is synced. How do you handle the conflict resolution? Which of them wins, right? And this kind of process. Another aspect, delta sync. That means, and we talked about, touched on this before. All the data you're transferring between the cloud and your device, essentially you're paying for the data volume, right? So that's something to consider. You would like to perhaps limit, the amount of data that is moved as much as you can, and then also considering that maybe connectivity is available, but the bandwidth is really, really slow. So the data is transferred really slow. You do not want to move large documents back and forth. You would want to make sure you only essentially synchronize and move the changes that that were made to the document. So instead of moving everything, you just take essentially the fields that have changed. So if you look at this, different kind of architecture, instead of following this client-server approach, using REST or GraphQL, we use a complete different approach where the application is working directly against the database, a local database that contains all the relevant information, or talking about ACL and so on, everything that you're allowed to see or the person logged into the device is actually allowed to see and work with. From a development perspective, that means you do not do any calls to web services, or there's no need for API gateways on the clusters on the cloud side. You can entirely work and focus on solving the business problem you're trying to solve, or your application is trying to solve. So that means focus on the logic from a development perspective, and then you have all the possibilities in order to do everything around the capabilities your application needs to support. Could be doing machine learning directly on the device, could be querying data using SQL, can be doing full text search text search queries directly on the device, predictive queries, and so on. So, for example, encryption and all these kind of aspects are taken care of. So, from a user perspective, also ideal because you have a rapid response, no matter if you have connection or not. Very easy from a development perspective. You work directly towards a native JSON database, essentially. And then, of course, you have the synchronization through the internet or whatever network you have. Can be your private network, of course. And this synchronization essentially takes place whenever connectivity is available. And from an application developer perspective, you can also choose, okay, what type of replication do I want? Do I actually want to replicate continuously, or do I only want to replicate at certain occasions? So, for example, if you think back at the example with the vessel, with the boat, you may be collecting data, but you do not necessarily want to sync the data because you need it later on to analyze, in the cloud. But considering that you may be connected using satellite, which is quite expensive, you would want to wait and delay to sync this information until you actually reach the shore and can have like a regular mobile network connection, for example. So different options, essentially. So just some example, we talked about so I pretty much focused on edge devices, where you have the cloud and you have the device data on the device, as for example UPS. But then, another aspect are edge nodes, where you have smaller data centers in the warehouse, in the store, on the boat, really where you need to get the work done. And the example or the demonstration I will give in 2 minutes is actually about, a warehouse scenario and how that can work. Just want to bring this up briefly as an example. If you think boat or vessel, we think a lot about IoT, and of course it's also a valid use case and quite often used. But here, it's, in the case of Carnival, it's a completely different story. It's about it's about entertaining the customers. They take I don't know how many people actually fit on the boat, but essentially they try to give them best possible experience, right? They buy their ticket, and of course, it's in their interest to upsell as much, products as possible. So essentially, everyone joining the journey, they get a necklace or something with some, RFID tag. They have plenty of tag readers all over the boat. So essentially, what they do in their local data center, they capture all the information from all the passengers on the boat, and are able to analyze this data directly on the boat, on the fly. So that means if lots of passengers, they move to a certain area of the boat because there's a bar, for example, they can then start campaigns. So buy 2 for 1, they can make sure they have extra staff at the right spot, and so on. And of course, this medallion, I'm not sure if it's a wristlet around the neck, but essentially, you use also for payment, you use for opening, the doors and everything. So, if you opt in, all this information is collected and then allows them pretty much to offer you, a good experience when you, for example, use their services the next time on a different boat. They know what wine you like and, all these kind of things. So I think that's a pretty nice story. Okay. Yeah, and there are more use cases. I don't have time to go into this because I would like to focus on a demonstration. But everything that has to do with field services, utility workers, going inspecting wind farms and so on. They essentially can sync, all relevant information, for those power stations that are going to control with all the documents and everything onto the device, and they are then able to essentially work with this and update and do whatever checks they need to do completely offline, right? They do not need to be offline, but in many occasions there may not be connectivity, so they can continue working. I think I mentioned mobile clinics, for example. And from when it comes to disconnected edge, It's, yeah, for example, there we have the cruise ship example again. Hospital, imagine, the doctor being able, they have all the patient information, no matter if connectivity is available, the network is slow, they can just do whatever they need to do. So in the beginning, I was not talking about user experience, from an end user perspective, but in those cases, it's really of enabling the workforce being able to do the job as efficient as possible. Okay, demo time. So before I start the demo, I just want to show or give you an idea what the demo is about. It's an inventory application in a warehouse. So you have a warehouse with stocks of butter and all the different products essentially that reach the warehouse and are delivered out to other units. And in this example, essentially, I have my master database or data store in the cloud, essentially aggregating all the data from all the different warehouses where the data is updated and maintained. And from there, I can then continue processing the data, make analysis on how popular certain products are. For example, I can integrate this into I know I've got. I don't know the term, but at least make sure that you order sufficient amounts of the certain items once they run out in stock of the different warehouses essentially. So you have all the processing analytics capabilities that you need in the cloud, like aggregating across all the warehouses. And in the demo, I'm working in we are in one single warehouse, essentially, and we have our employees. The employees, their responsibility is essentially to count the amount of items. How much butter do we have? Okay, how much of this do we have, and so on. And they operate on, in this case, a mobile phone. So we use simply mobile phone. And of course, they do not work in isolation. They work in teams. So a couple of persons maybe going around, doing the calculations and updating the system, essentially. That then also allows, for local processing and update of the inventory data. So how does the architecture or the stack look that's actually used in the demo? On the right-hand side, we are in the cloud. For the sake of the demo, I'm using AWS. Could be any cloud provider, can be your own data center, if you like. And essentially the components involved are Couchbase, the database that I introduced at the very beginning, that is kind of holding the full data set of everything across all the warehouses. And then this data is exposed through something called app services and an app endpoint. And the responsibility of app services and the app endpoint is really the synchronization aspect that we talked about. Taking care and also considering, all the aspects that are of importance, making sure the data is sent as efficient as possible. Do not waste, do not send huge documents. Send only the changes. Make sure you have access control in place. That only the right team is allowed to, do inventory at the right place or for the right products, and so on. So that's essentially the cloud side. On the edge, on the mobile device, we have an application. It's written in Kotlin. Could be any language really. The application is exclusively working, and I will show that. It's exclusively working towards a local database, which is Couchbase Lite. Essentially, think of this as Couchbase but small. Essentially, so a native JSON database. And of course, what you also need is local storage. So the data needs to be persisted somewhere. In our case, it's mobile phones, could be a Raspberry Pi, could be any type of device that has or provides local storage, essentially. And then with the users, they interact with the application. Okay, so let's hope that works. I'm going to use two emulators and I use 2 different Pixel phones, so maybe they look so that they look a bit different. Okay, so one I had already started. This is my inventory application. I can now log into the application. In this case, it's the user demo. Yeah, and the other phone is still starting. So I'm logging in here. The first thing I want to do now is to enable the replication. Obviously, in your application, you wouldn't want to enable the replication manually. I do this, for the sake of the presentation, pretty much. So I make sure, I have the phone has connectivity, internet connectivity. So I will make sure to just set up, kick off the replication, and just for you to see, I choose to push and pull data. So essentially, the data will flow both ways, and I will make sure it's continuously pushed, or the data is continuously updated as there is internet connectivity available. So I save this, I start replication. Now the replication is running, and I can now start, using the application. You can see I have a couple of different warehouses. We can just navigate in here. It's a bit difficult to navigate with the touchpad. So different type of products. If you just go back to this one, what is it? Cheese product. Let's say, okay, I update the inventory. We only have 11 left. Okay, I save the changes. So essentially, I'm working locally, and what's happening now under the cover is that the data is synchronized at the same time, right? I will go then also offline and show you that, okay, now I work without internet connectivity. I'm logged in, let's just quickly check. I'm logged in as a user called Demo, and Demo user, it's difficult to see. He belongs to team 1. I use the team in this context for access control. Say, okay, everyone in team 1 is allowed to operate and work on exactly the same data set. So I will now, on the other phone, log in someone else, which is called Demo 1. And Demo 1 actually belongs to the same group, so he should be able to see, has the same rights on the same data set as the demo user. So I do this, log in. Logging in. Currently no data is available locally, and because the replication is not enabled, as I mentioned before. So I just make sure I also replicate the data here. It's the same configuration. Start the replication. And now the replication is running. And if I now jump into here, I can see, look, actually I'm working on the same warehouses, right? So if I jump in here, see, okay, the same set of products. Okay. Let's update something. Where is it? Okay, they're in a different order. Apologies. They're sorted differently. So if you look at the cheese up here, which appears down here, and now you have to be, just keep an eye on this one down here. So now I go into the cheese product, and I make change to the amount. Okay, we only have 1 cheese left. I save it, and as we can see in the other application where the other users logged in, essentially the count was updated pretty instantly. And what happened now is, or what actually happened in the background is, in the application on the left phone, I made the change locally in the database, and then this magically, the replication simply happened, or the synchronization simply happened, towards the cloud in AWS, which is, I think, in Ireland for the setup, and essentially was synced back to the other phone. So it was pretty instant. This change. If I maybe just checking time. Okay, I have time left. I also want to leave some room for questions. So if I take the phone now and say, okay, that was very unfortunate, but now the phone is disconnected, so I don't have any internet connectivity anymore. Let's go. No, we go. Let's take warehouse 101. It's empty at the moment. it's of course also empty on this side. So now the phone on the left-hand side is completely disconnected. It's difficult to demonstrate slow connection, so it's better to demonstrate no connection. So no internet available. But anyway, the application is still functioning exactly the same way as before, because nothing has changed from our application's perspective, because we are working towards a local database, right? So I decide to add, for example, a product to this warehouse. I do text search directly on the local database that I have on the device, right? No internet connectivity. Nicht cheers, cheese. Yeah, no internet connectivity is available, but I can, search a full data set. So I take any product, make up some count here, and of course then it's only available at this point on my device. Because this is on device, because there's no connectivity established. Oh, there's no internet connectivity for this device in the moment. At the same time, demo one, my colleague, he is perhaps scanning some other type of products, IPA, or counting other type of products, IPA, saving the changes. Now, obviously, they are not in sync, right? Because one of the devices is currently not online. So let's try this out. Oops, sorry. Like this. Let's get out of the airplane mode. So, and here we go. So the connection was established. From an application perspective, I didn't do anything. Essentially, the synchronization took place by itself. The connection was reestablished, and the synchronization could happen. Right? Now again, it's a different order. So we see we have the same count for the cheese here and the cheese here. Then of course I can operate and work on either side of the applications, and it will work. Now you may wonder, okay, what happened? We talked about conflicts. What may happen if there's a conflict? If one of them is offline and they kind of count the same product, what will happen? Let's try that. So if I go offline again, and then let's take the IPA. I say 1 is left. Okay, now my colleague comes, and they just restocked it. And he's like, oh, it's actually 200. Oh, yeah, 2001, whatever. Okay, so of course, now they're not in sync, but once connectivity is available, there will be a conflict, right? And the conflict needs to be resolved. Did I not up? It was. Didn't I? The cheese up here and the cheese is down there. I did. Oops, thank you. That would have been an interesting. Thank you. Okay, so IPA and IPA. All right, one IPA and the IPA was restocked. Apologies. So I now turn the connectivity on out of airplane mode. Let's see what happens. Okay, you see, the local change I made here, one was actually overwritten by the change I made on the other device. Has nothing to do with I was offline, he was online. Instead, it simply is the conflict resolution mechanism you choose, right? Because different use cases require different mechanisms. In this case, it's based on the timestamp. So the most recent update to the document will win over the other update. And there are, of course, other mechanisms you essentially can choose. Or for some use cases, you may want to implement your own, simply plug in your own mechanism. Maybe this particular user is the super user, and everything he does should override what everyone else does, right? Okay. I think that pretty much concludes my demonstration. Just to show one more thing, we have the user demo here, right? That is in the same team as demo 1. So let's log out demo 1, and let's log in a different user, right? Using the same device. So let's log in him. Okay, no items in database because I need to replicate this case. So I kick off the replication. Oops, didn't I? Interesting. Anyway, it's supposed to download some other warehouses. I'm not sure why that didn't work now. But anyway, looking at the demo user that belongs to team 1 and looking at demo user 2 that belongs to team 2 essentially means they are not operating on the same data set, right? So here, demo 2 cannot go in now and change the amount of my EPAS in my warehouse, essentially, right? Okay. I hope that was interesting. And do you have, we have 4 minutes. Do you have any questions? Please. Okay, the question is, okay, if your device is offline, how do you mark the changes as pending? Yeah, essentially that's essentially done under the cover, right? From an application perspective, you wouldn't worry because the only thing you know or aware of is, okay, I store the data in this database. Then essentially, of course, there is metadata with the documents. That will contain information. Okay, is this pending? Was it delivered? Was there a conflict? You know, all this kind of information. Of course, is also stored together with the documents, but it's nothing really you would see or probably also not need to worry about. Any more questions?
How do you define how much data or what part of the database one device can receive?
Yeah, so it's based on access control, essentially, access control rules. You essentially define, it's pretty much free for you to define, okay, yeah, you essentially define via access control, okay, those documents belong to a certain channel, access is the internal term, a certain channel, and then you can grant access to the users to one or multiple channels, essentially. And that's how you control this. In addition, you can also further restrict, the amount of documents that are moved. But yeah, it's kind of the ACL channel concept that makes it work. Do you have any more questions? No? Thank you.